Hello, I'm recording this video because I'm just finishing this custom homemade DIY rainwater harvesting system, and I thought some of the things that I learned along the way might be useful for anyone else who is trying to do something similar. This is kind of a little hobby project. It was something I always wanted to do. Is a simple, zero energy, gravity based rainwater harvesting system, and when we're building this house I ensured that there were kind of some services and plumbing left up in this position so that this could be achieved. The situation we have here is we've got an upper roof which drains down a pipe here, so all of the water collected on that upper roof flows down through that pipe, and I wanted to collect as much of that water as possible for use in toilets and pressure washing and watering plants and stuff. So the idea here was to maximize, within very limited space, the amount of water that could be captured, and also to minimize the cost of the overall design. So it's using mostly off-the-shelf kind of parts, and I'll explain each part as we go. Before I go any further, I'd like to just mention a guy called David Alexander who gave me some good advice along the way, a few pointers and advice, and also supplied some of these filters that I'm going to show now. So first I'm going to give a quick run through of where the water flows in this system, and then I'll explain each part in more detail and the thought process that went into it. The water comes down this pipe here, drops through this primary coarse filter into this tank. If this tank is getting very full, these overflows will take the waste down the main drain. The water flows out through the bottom connector here, through this finer filter, and into this tank. This tank, because it's passed through the fine filter, should be fairly sediment free. It also has an overflow, two overflows, which I'll explain later. And here is a totally mechanical mains backup, which when the level drops to a particularly low level will add in a bit of mains water so that the system can be used continuously, even if there's no rain. So let's look at each part in a little bit more detail. First of all, we have the rainwater coming in through an 80mm drain pipe, and it passes directly into this. This is a 3P Technik Patronen filter designed for this kind of purpose. Normally a much larger kind of scale, I think, but it works well here. If I open that, you see there's a stainless steel gauze mesh filter which the rain passes over. So the rain will shoot down here, pass along here, and unless the filter is blocked, it'll all pour down this pipe here below into the tank. If the filter here gets totally blocked, or maybe if there's ice in the tank and the water cannot pass down the vertical pipe, then the kind of fail-safe is for the water to go through that pipe and then down the main drain. This inlet filter is connected via this vertical pipe to a calming inlet, which you can see below the water line here. The idea of that is that the dropping water that's entering will not disturb and upset any sediment that might have built up on the bottom. You could easily make a kind of DIY one of these. This came with the filter, also by 3P Technik. Over here we've got two overflows. Now the inlet is 80mm diameter circular pipe. These are two 43mm diameter circular pipes, as you can see. The total diameter, if you were to combine these, would be equivalent to maybe a 60mm diameter pipe, which is okay. If you're doing this, you'd want to be careful to ensure that the overflow is roughly, similarly sized to the inflow. Otherwise, the flow in could exceed what these can handle. I used two smaller pipes instead of one larger pipe because I wanted to maximize the vertical water level possible in this tank. So having two side by side is better than having one large one, and that's why that's done that way. The outlet down there is just a little bit above the base of the tank, and that should hopefully stop large sediment getting sucked through into the next tank. This tank I don't really consider important to keep particularly clean because of that secondary filter along the way. Moving over to this stage, we have the outlet of the first tank, as you can see, and it passes into this secondary filter. This is a much finer filter, which actually takes a bit of pressure for the water to go through. Not very much, but still it does reduce the pressure a little bit. Now, part of the design of this, because I wanted it to be totally gravity based, was that I didn't want any filter on the outlet of the main tank here, because that would reduce the pressure and flow of the filling of toilets and so on in the house. So I wanted to maintain like a zero pressure drop between the tank and the use points of the water. Obviously 0 is impossible, but as close to that as possible is what I was aiming for. So this is between the two tanks, which means this tank here is kind of dirty, this one is kind of clean. You'll also notice that this tank is on 2 blocks of insulation and this one is only on 1. That height difference allows for this tank to be backed up with the mains, but when it fills up only to about this level, there's no chance of water flowing back into this tank, which would be kind of a waste. You want to try and minimize the amount of mains water you're using to do the backup. So by having the split level, not only did it allow for this filter to fit in, but it meant that water would not pass back in this direction. No mains water would pass back in that direction. This is just a little valve to drain this tank, and we have a tap here connected directly to that tank, and this is a visible overflow, which I'll explain in a second. Okay, so onto the secondary tank here. This is the clear water tank, which has been filtered through the fine filter, so there should be no little particles here. Anything you see floating on the top now is just stuff that's blown in since the lid was removed. Okay, I'm going to explain a few things. So the main thing in this tank is this mains backup. This ensures that in a dry spell, when you haven't had rain a lot and you're still using the system for filling toilets and so on, that the level, a minimum level, is always maintained. And the way it works is there's a float underneath the water, as you can see, and it's the density of that float is pretty much identical to water, so there's virtually no tension in this cord at all. As the water level drops, the string keeps the float eventually above the level of the water, and then this arm gets pulled down. And when it gets to a certain point, the backup begins, and that will last for a few centimeters of rise of level until the float has risen sufficiently, and then it'll stop. So you can maintain your minimum level to within a few centimeters, which is great. Another very important thing about this is you see the inlet there where the water pours in. That needs to be maintained, a certain distance above the surface of the water. There's a regulation about this, and it says something like the distance there should be at least double the diameter of the inlet pipe. So we have a 15mm inlet, so I have about 35mm of an air gap here, and that prevents any water ever potentially getting sucked back into the main system, contaminating the main system with rainwater, which would not be great. So even though you're losing a bit of space in your tank, it's very important to maintain this air gap. Just point out this, I have a couple of these around the side, and I wanted to make sure, because this tank will be covered, I wanted to make sure air could come in, so there'd be no pressure problems with water coming in or going out of the tank, just to basically ventilate as well. Because when the lid on, it's a fairly tight seal. So the level here to 35mm is maintained because over here we have another overflow. If the water level rises here sufficiently, this overflow will be used, and even if the mains backup is fully on, it rises up a little bit and the water just goes down there and the level never gets any higher, which is what you want, to maintain that air cap. This here is another overflow. This is to enable a visible overflow. So if you see inside here, in the side of this, I cut a little hole, and this allowed me to regulate the distance between this overflow and this one perfectly. So when the water level rises really slowly, this one will start to be used before this one, and that allows you to identify. So you can see here there's a few drips coming out because I topped it up there a second ago. That allows you to identify if this valve is faulty. If this was dribbling a little bit or if it was stuck on, you want to make sure you know about that sooner rather than later, because otherwise you'll be wasting a lot of mains water. So if that happens, the water level rises, and before it goes down the main overflow, you get a little dribble out of this overflow. This will also happen when it's raining, which is why I put the watering can here to collect any stuff that pours out of that. But if you start seeing drops coming out of there when it's dry and it hasn't been raining, then you know there's a problem which you need to fix. Okay, so that's the system, and I hope this video is useful if you were planning to construct your own kind of system like this. I'd recommend, I spent a lot of time thinking about the different levels and all the kinds of things that could happen or whatever, because it was such a small space and I wanted to make sure this was worthwhile, even if it was a bit kind of like an exercise in just seeing if it's even possible, but still I wanted it to be useful, and I tried to do everything I could to maximize the volume in the tanks and so on. But don't be too concerned about the levels. Like, it's not an exact science in the end. You have to play around with it a little bit. That's why, for example, this overflow, I started trying to cut this hole exactly at the right position so that this will be slightly higher than this, and eventually you just realize it's easier to do something like this. Cut a little hole in the side, twist it round so you can just manually very finely adjust the difference in height, because when you're drilling and when you're cutting and stuff, you're not going to get it to 0.5 millimeter precision. Okay, so if you have any questions or comments about this system, or if you're planning your own stuff and you have any questions and I might be able to help, just leave a question or comment in the comment section, and I'll try and get back to you if I think I can help. Okay, well, that's it, and hope it was useful.